All right, let's do some more examples of substitution. Okay, so here's one. This one looks as if there's nothing to substitute there. So step one is to rewrite this in the form of sine of x all over cosine x so that we have some things to play with. Okay? All right. Now, what's going to guide us here is we want to call something u. And initially, we're not sure what to choose, but we want to pick the u so that it'll simplify some stuff in the integral, but we also would like to see its derivative there, because when we see its derivative there, then we know we're going to win. So the trick is to say, oh, I should let u be the cosine of x because that'll simplify the denominator a lot, and its derivative, at least up to a constant, is the sine. So I see the sine there, sine dx, and so that is the sign of how things, of things working out for us. So let's try. U is equal to the cosine. So du dx is minus the sine. So we can solve for du as minus sine x dx. Now we don't see minus sine x, so I'm going to throw the minus on the other side. Minus du is the sine of x dx, and that's what we see here. So let me rewrite it here so I can write on it. So this part here is just going to become minus du, because there's the sine x dx. Sine x dx is minus du. And that cosine is going to turn into just a u. So I end up with, pull the minus out because it's a constant, du and 1 over u. And we know how to do that. That's no problem. Minus the log of the absolute value of u plus a constant. And then don't forget, u, way up here, was the cosine. So it's minus the log of the absolute value of the cosine x plus c. And we're done. All right, let's try another example. This one's has one further complexity to it. So it's the integral of x, the square root of x plus 1. All right. Now, it seems reasonable to want to try u is equal to x plus 1 because that looks like the complicated part inside of the square root. I'm not as confident it's going to work because I don't see the derivative immediately staring at me, but the derivative is 1, so can't be that much of a problem. So let's just try it and see what happens. Often with substitution, we just have to try it. So du dx is 1. So in this case, du is dx, so that'll be simple. So the dx will just change to a du. This x plus 1, hooray, will just change to a u. That's nice and simple. But the x, what am I going to do with that? Okay, initially I'm not sure what to do. But then I say, oh, well, I need to change it into a u, but I can do that because over here I could have solved for x. X is also equal to u minus 1, and that's the thing that I can use over here. Okay? So the x will just get changed to a u minus 1. Okay? All right, so that's a new thing where we had to go back and solve for x and plug that in. All right, so this integral then becomes the integral of u minus 1, the square root of u, let me write that as u to the 1/2, into du. And this you should multiply out as u to the 3/2 minus u to the 1/2, because that way they're pure powers and we know how to integrate them. So that had to come from the 5/2 power. We need a 2/5 to fix it. And this had to come from the 3/2 power, so we need a 2/3 to fix it, plus c. And then don't forget, u was x plus 1, so I have to change that back. So the answer is 2/5 x plus 1 to the 5/2 minus 2/3 x plus 1 to the 3/2 plus c. That's it. Anyway, I think you'll enjoy substitution. It's just really satisfying. All right, ciao.